This lesson is about long division of polynomials. First, we need to recall some facts about division. A dividend, what you're dividing into, divides by a divisor, the thing you're dividing by. The result is a quotient, and there may be a remainder, which would then be divided by the divisor. Now, that probably sounds confusing, so let me give a numerical example. I could have something like 22 divided by 5. The quotient would be 4. The remainder would be 2 out of 5. We wouldn't just say 4 plus 2 because that would be 6, and that would be incorrect. Now, alternatively, I can say the dividend equals the divisor times the quotient plus the remainder. In the context of this example, then, I would say 22 equals 5 times 4 plus 2. So we want to keep these in mind when we're doing long divisions. If we were doing a long division statement operation, we would actually write 22 here, the dividend, 5, the divisor here. We would consider how many times 5 can be put into 2, or how many times 2 can be divided by 5 is another way to say it. The answer is none. So then we move one decimal place to 22, and 5 can be multiplied into 22 4 times. We then write 4 times 5, the result 20, underneath, and then we subtract these results, leading to a remainder of 2. So we want to keep this in mind. The 5, the 4, the 22, and the 2, their location and their meaning, because what we're going to do now is do it with polynomials. So keep this in mind. You may need to go back up and refresh yourself on that and compare. Okay, here's a polynomial that we're going to divide. The dividend is a quartic, degree 4. The divisor is a degree 2 polynomial, or a quadratic. So I would put the divisor here, and I would put the dividend here. So, one thing that's important when we're writing these is we need to account for all terms, degree 2, degree 1, degree 0, degree 4, 3, 2, 1, and 0. We also need to have them in descending order. The next thing I look at here, as is the case with 5 being multiplied out into 2 or 22, I consider how do I multiply x squared to make x to the 4? The answer would be x squared. So I put that answer in a column above the x squared place. Now I multiply this part of the quotient onto the divisor, making x degree 4 minus x cubed plus 2x squared. And notice how everything lines up according to the term degree. I subtract. This will always be 0 because I've selected the quotient correctly. This is for subtract negative or add 1, so 5x cubed. And I have negative 1x squared minus 2x squared, so negative 3x squared. I take one term from the dividend and bring it down, and I do the same procedure again. What do I multiply x squared by to form 5x cubed? The answer would be 5x, lined up under the x degree 1 column. I multiply this quotient term onto the divisor, writing the result here. 5x cubed minus 5x squared plus 10x. I'm going to subtract these. This will always be 0. This is going to be negative 3 subtract negative, or add 5, so 2x squared. And 2x subtract 10x, so negative 8x. I'm going to borrow a term, bring it down. Same process one more time. I multiply x squared by 2 to form this term. So let's do that onto all the terms of the divisor. We'll subtract the result. These cancel. This is going to be negative 6x and minus 2. This is the remainder. So I can say that the solution is, or the equivalent statement is, x squared plus 5x plus 2 minus 6x plus 2. Notice how I borrowed the negative and factored it out over the divisor and I got my sign wrong there. That needs to be a minus sign. That's one way that we could write the answer. We can use the other form of the division statement as well. Okay, you try this one and see how you do, and then come back and join my solution. First of all, just check your work. Did you recognize that you were missing a term in the divisor and the dividend? You need to account for those. All right, so let's work through this now. I have x cubed 0x squared minus 2x. Subtract the results. 4x squared plus 2x. I'm going to borrow that term, and I'm going to write a 4 here. 4x squared, 0x minus 8. I'm going to subtract those, and I'm going to get 2x plus 9 as my remainder. That allows me to say that x cubed 4x squared plus 1 divided by x squared minus 2 is x plus 4 plus 2x plus 9. Now we don't leave it like that because that would simplify to 3x plus 13, indicating that that's the quotient, and that's not the quotient. Look up here. I need to divide by the divisor. Now I can also write this. I can say x cubed 4x squared and 1 equals the divisor times the quotient plus the remainder. All right. Couple of things to let you know about that I mentioned before, but I've written them here. It's important to write all terms. You use a coefficient 0 if needed, if a term is missing. It's important to write in descending order of exponent. Don't have squared, linear, then cube, then a constant, or something like that. Now, if your divisor is a linear binomial, use synthetic division. A linear binomial looks like this: x minus 3, or x plus 5, or something like this. Okay? Synthetic division is covered in another video. Watch for that one. It follows based on the understanding of long division covered here.